Hello viewers, welcome back. In this video lecture, we are going to talk about the classification of organic compounds. How the organic compounds are classified. Here, I listed out two main categories. One is a carbon skeleton and another is a functional groups. Now let us talk about the carbon skeleton. Here the carbon skeleton means how the carbons are connected. So that is, maybe you can call it as a structure also. Okay. So based on the carbon skeleton, so we divided into two categories, that is open chain compounds and another is cyclic compounds. So in the open chain compounds, how it will look like? So they may be a straight or branched chain. Here you see I given the example for this one, the straight chain. So here it is a butane. You see this all are connected like this. So branched means it will be in this form like this. For example, I am drawing like this. So this is a branched one. This is 2-methyl propane. Okay, so this is 2-methyl propane. So this is a branched one, and they are not in a ring form, okay, because these are open, okay, this is not closed, and it may be saturated or unsaturated. For your kind information, I already posted a lecture about the saturated and unsaturated compounds that I given in the description link. Please go through that, okay. So this is how the open chain compounds may exist. Okay, it may be straight or branched and maybe in the form of saturated or unsaturated. Okay, and these are the examples. Okay. Now let us come to this cyclic compounds category. Here these compounds may be classified into two categories, that is aromatic compounds and alicyclic compounds. Let us finish the alicyclic. Alicyclic means the word ali means it came from the aliphatic, and that is cyclic compound. So these compounds are resembles like aliphatic compounds, but these are in cyclic in nature. That's why we call it as alicyclic compounds. So these are the examples like cyclohexane and this is cyclopropane. Now come to this category aromatic compounds. So this may be further divided into three categories, that is benzenoid, non-benzenoid and heteroaromatic. You see this is a benzenoid. So this example is benzene. So this categories mostly they contain as a parent structure as a benzene. This parent moiety benzene will present. So such compounds are called as benzenoid, and these are also aromatic in nature, that we should remember. So we can learn more about the aromatic, non-aromatic and aromatic in the forthcoming topics. Okay. Now non-benzenoid, that means it won't contain benzene like structure, but it behaves as an aromatic compound. So that compounds are called as non-benzenoid. Again I repeating it. So this will not having any benzene like structures, but these compounds can behave as a aromatic compound. That compound are called as non-benzenoid, but it is aromatic. And third category is heteroaromatic. Heteroatoms in this benzene cyclic compound, if the carbon is replaced by any other atom like oxygen, nitrogen, sulfur, these are called as heteroatoms. Here the heteroatom nitrogen is placed, so these compounds are called as heteroaromatic. Heteroatom is there and it is aromatic in nature, that's why we call it as heteroaromatic compound. Okay, so these are the classification of the based on the carbon skeleton, how the compounds are classified. Now let us see how the second category, that is based on the functional group, how the compounds are classified. Let us take this example. These are the classes, different classes, alkane. So mostly it will contain, this is single bond, carbon connected with a single bond. For example, like this. So this is butane. You see, all the carbons are connected with a single bond. So that compounds are called as alkane. Alkene means you will have this double bond. You see, I am putting the double bond here. You see, this carbon is having a double bond. So why this compound called as alkene? So this is, the structure name is called as butane. And this is butene. You see, this is 1-butene because it contains ene, alkene. Now alkyne, how do you call it? Because it is containing a triple bond. For example, like this, I put triple bond. So this is propyne. Sorry, here 4 compounds. This is butane, 1-butane. Okay, and this is alcohol. OH group means it is an alcohol. That means, for example, this is CH3OH. So how do you call it? It is methanol. So this compound name is called as methanol. And ether, it is having the linkage COC. For example, like this, CH3, CH2, O, CH2, CH3. You see, this is connecting, that oxygen is connecting with these 2 carbons. This is ether linkage. So why this compound name is called as diethyl ether. Diethyl ether. Now this is an aldehyde, C double bond OH. For example, this is CH3, C double bond OH. So this we can call it as an acetaldehyde. Okay, aldehyde. And this is ketone, C double bond O. This functional group is called as ketone. If you draw like this, so this is acetone. You see, this is acetone. Carboxylic acid, this is COOH. For example, like this. So CH3, CD double bond OH. So this is an example for carboxylic acid. So we can call it as an acetic acid. Amine. So this NH2 group is called as amine. For example, CH3 NH2. So you can call it as a methyl amine. So these are some different functional groups. So and these are the main characteristics. OH means alcohol, COC, ether, C double bond OH. This is aldehyde, C double bond O ketone, carboxylic acid, amine, NH2. So these are based on functional groups, and the first category is based on carbon skeleton. I hope you understand this lecture. Kindly subscribe and share it if you like this video lecture. Thank you very much.